In this lecture, let's begin preparing the player. In our scene, we have a placeholder for a player. It's useful, but it's time to replace it with an actual 3D game object. Let's quickly create a player with Unity's 3D models. First, we should update the name of the game object. Set the name to player. It's not going to be a placeholder anymore. Next, change the icon to none. In a moment, we're going to add a real object. The icon won't be necessary anymore. In the transform component, reset the values. The player game object should be a prefab. Before converting it into a prefab, it's considered good practice to reset the transform properties. This will avoid weird behavior in our game. Time to create a 3D object. In the hierarchy, navigate to the Create menu. From this menu, select the 3D capsule option. Afterward, reset the transform component. Next, move the capsule game object into the player game object. Lastly, let's create a prefab from the player game object. To keep our project organized, create a new folder in the Assets directory called Characters. Drag the player object into this directory. Great, we've got a prefab. During this process, you may have had one question. Why are we using nested objects? Let's enter prefab edit mode for the player. The player has two game objects. The first game object has the minimum setup for an object. It's just an object with a transform component, whereas the child game object has the capsule mesh data. Wouldn't it make sense for the capsule to be the parent object? In the programming world, we have a principle known as separation of concerns. This principle is not specific to Unity or C#. We can apply it to any programming language or framework. In fact, we can apply this principle to the real world. Hospitals can employ hundreds of people. There are surgeons, nurses, techs, chefs, janitors, etc. Each person is given a specialized job. Not a single employee performs all jobs. You can apply this concept to almost any industry. Businesses will always assign specific responsibilities to each employee. This principle can be applied to programming. We may have hundreds of game objects and classes. The separation of concerns principle states that we should split our logic by responsibility. This principle keeps our code base clean and organized. Back to our prefab. How does this principle apply to our players? Our player is going to have dozens of components added to it. We need support for collision, movement, quests, combat, health, and so much more. If we were to assign the components to the capsule, this object would be responsible for everything. This can give us trouble. Let me give you an example. In my editor, I've created a new prefab. You do not need to repeat this process. This is purely for demonstration purposes. Unlike the other prefab, this prefab has a single game object, which is the capsule. Seems fine, right? Not so fast. In the future, we're going to swap the capsule with a different object. Let's give that a try. In the hierarchy, create a new 3D model. This time, let's use a cube. The cube is a child object of the capsule, but that's not what we want. The cube should replace the capsule. Unfortunately, Unity does not make this process easy. Child and parent objects from a prefab cannot be easily swapped. Therefore, we must disable the mesh renderer component on the capsule game object. This achieves the desired effect. Unfortunately, we're wasting resources. The parent game object must be active for the cube to render. At the same time, the mesh for the sphere is being loaded through the mesh filter component. While not being used, the data for rendering a capsule is being loaded in our game. We can use separation of concerns to avoid this scenario. By using an empty game object, the visual information of the player can be easily swapped. In most games, Developers will use child objects to handle visual rendering. Parent objects are responsible for the logic of the prefab. If the child objects get replaced, the original behavior and logic for the prefab will remain the same. Thus, it'll be easier to upgrade a game object. This pattern does not need to be applied to all prefabs. For example, our tiles don't follow this pattern. Unlike the player, tiles will not require complex components, nor will we need to swap their visual information. They'll be simple compared to the player. Let's finish working on the prefab. While testing movement, the player should be facing the direction they're moving. At the moment, it's not easy to tell where the player is facing. We can use the Select tool to remind us. However, it would be nice if we could skip this tool. To resolve this issue, we can add another game object to act as the front face. In the hierarchy, enter the Create menu. Create a 3D game object called Cube. Next, let's move this cube to the front of the capsule. You may need to resize the cube during this process. It should be smaller than the capsule. As a reminder, the front side of an object is the direction of the blue arrow. To take this even further, let's change the cube's appearance. In the Project window, switch to the Materials folder. From this directory, create a new material. Set the name to Temporary Player Face. The albedo option will be set to a blue color. You can use whatever color you want. Next, drag the material onto the cube. Great, the player is ready. Let's switch back to the scene. The player may not be visible from the scene. This is because we've reset their position. Let's move the player to the original location, which is the bottom right corner of the map. The player should sit above the beach tiles. It doesn't have to be perfect. As long as they're slightly above the ground, that's good enough. In my opinion, the player is too large for the map. Let's quickly resize them. Head back into Prefab Edit mode. I'm going to resize the player's scale to 0.3. All scale fields should be set to this field. Be sure to modify the capsule, not the parent object. Since child objects are responsible for visual information, they should be affected by our scaling. Next, the cube may need to be rescaled and repositioned. I'm going to quickly adjust the cube again. These changes should create a smaller player. Let's head back to the scene. The player may be elevated off the ground. Let's adjust their position to be slightly above the ground. Lastly, the player is facing toward the cave. I'm going to rotate them slightly to the left. Rather than facing away from the camera, they can face to the left. Fantastic! The player is ready. In the next lecture, we can start writing a class to handle the actions from our game.